Hello there and welcome back to Steam It with Steve. Today we're going to go through the next step in our Introductory to Python course. And what we're going to do is we're going to learn about conditional statements. So conditional statements are as simple as this. If something is true, go this way, otherwise go this way. That's literally what happens with it. And we're going to look at how the Python language works with that, with the three different ways of if statements work. Okay, so let's get into this. So this is an if statement here written in Python, and it's pretty much reads it just like English. So if you are good equals true, then you get ice cream. Else you get broccoli. So here's the little statement here, and this is, I've made a simple little flowchart. So the question is, are you good? If that's true, you get ice cream, right? So that's those first two statements. Otherwise, or if it's false, you get broccoli. So you see that there's only two choices that you get to do, but either if this is not true, you go this way. If it's true, you go this way. It does all the possible conditions. Okay, so we're going to break this down and have a look at this structure that's in here. And yeah, should be a lot of fun. Here we go. So the first important symbol, whenever we deal with in Python, this is the most important symbol that you will use for any control structure. Okay, and it's a colon. Right. So with my students, usually I joke because we're dealing with Python, it's a snaky bite. Okay, so I'm going to use the terms in betweenly saying snaky bite or colon. When I say snaky bite, just means that. Okay, so it means that you've done a snaky bite because something important is about to happen. Okay, so whenever we use a control structure like an if statement or a loop, anything, we need to have a snaky bite. Otherwise, the program doesn't know what's happening. Okay. Cool. So here's a bit of a dad joke. The problem about being a programmer. My mum said, honey, please go to the market and buy 1 bottle of milk. If they have eggs, bring 6. I came back with 6 bottles of milk. She said, why the hell did you buy 6 bottles of milk? I said, because they had eggs. Okay, so a bit of a bad joke. If you look here, that's the logic. So if they have eggs, which was true, bring 6, and then he goes back here and he bought 1 bottle of milk, but he brought 6 bottles of milk. Okay, bad joke, I know, sorry. Here we go. So what we're going to have is a whole heap of these logical conditions that we need to evaluate, and whenever we check this out, it's going to evaluate as either true or false. Okay, so these things here in Python will try and evaluate it and come back with a statement of either being true or false. Now, when you're checking to see if something is true, instead of 1 equals, we must use 2 equals. Okay, because if we remember, 1 equal was the same as assignment. So if we go x equal to 1, it would assign the value to 1. So the way that Python handles this, and a lot of programming languages does this, is they use double equals. And double equals means that you're checking to see if this or this. So double equals means for comparison, single equals means for assignment. The next one then is not equals. So you'll see an exclamation mark equals sign. That's just checking if this thing here is not equal to this. And then you've got something else you can do. And then we've basically got the less than and greater than symbols. So if we've got A less than B, or A is greater than B, or we've got A is less than or equal to B, or A is greater than or equal to B. Okay, so there's a whole heap of different options here that you get to choose from. And you just need to use the appropriate tool for what is being compared. Cool. So basically, once this gets evaluated, it will either come back as true or false. So my question then is, what's the difference between equals, equals, and equals? And if you're just listening just now, you'll understand that there's 2 different versions. So when you see a double equals, it's an equality operator. So basically, it's checking to see if it's true. If it's a single equals, it's an assignment operator. So double equals will always find the truth of a statement, okay? And it always returns a value of true or false. An assignment operator is a little bit different. It changes the variable's value according to its type, if it's a character or if it's a bit of text or a number, okay? So assignment is 1 equals, double equals is an equality checker. Awesome, so just pause the video there. Have a go at these ones in your idle. So try the following conditions to see what Boolean output you get, true or false. Make A equal to 1, B equal to 4, C equal to 4, D equal to 5. And then just type those lines straight into Python to see if you get true or false. So just pause the video there and we'll see you soon. Okay, hopefully you had a good go with that. If I open up idle, here we go. So we're going to put in all those values that we've written up the top there. So we're going to go A equal to 1, B equal to 4, C equal to 4, D equal to 5. Cool. And we're not going to run it as a script. We're just going to save those values and type it, because sometimes you want to use the interpreter function, particularly for things like this. So A is equal to B. We do double equals, and that was false. If A is not equal to B, right? So A is 1, B is 4, then it will be true, because that's the opposite of it. A is equal to C. So does 1 equal 4? Nope, that's false. And then 4 is A is less than B. So is 1 less than 4? That should be true. So if we go A is less than B, it's true. If we go A is greater than B, you're going to get false, because it's the other way around. If you see C is less than D, that's, oops, sorry, not capital D, is true. And how cool is Python? Because it's told me what the error is. It said name D was not defined because it couldn't find where we've talked about it before. And then the last one, B is less than or equal to C. So is 4 less than or equal to 4? Absolutely. So that's true. Cool. So hopefully you've picked something up with those ones, and that's made sense for you. Okay, so we're going to talk a little bit more about this flow of control, which we briefly talked about before. What we're talking about is how does the information flow through in your program. So you can actually draw it up with something called a flowchart, which is what this is in the corner. And this helps you identify key structures that are happening. So when you see a diamond, that basically means a decision has to be made. So you either go true or false. And then when you see these square boxes, that means what happens when it's true. And then this box here means what happens when it's false. So if you look at this carefully, when this if statement happens, you have to either do this body of text or this body. You can't do both. So it's basically making you have to make a decision. Okay. So flow of control talks about the statement execution in a program. So is it sequential and it's following one statement after another, or is there things that change that flow? Okay. So there's three main control structures that will use that snaky bite or colon that we were talking about before. So one sequential structure is where the sequence of statements are executed in order. So just what we've done so far. The selection structures is what we're covering today. So this is where a decision whether or not to execute a particular statement has to happen. And the last one is repetition structures, which we'll be covering soon. So this is when you execute a statement over and over repetitively in a loop. The decisions, so selection and repetition, are based on Boolean expressions. So it's either going to be true or false when you sort of sort that out. Okay. And then the order of statement execution is what we know as flow of control. So I've got a little video here which hopefully will give you a bit more ideas. It's from the Big Bang Theory.
I'm curious, in the how well do you know Sheldon section, what do you put for
his basically makes an algorithm for how to make a friend.
Lysine. Damn it, I had lysine and changed it. Oh, good, you're just in time. I believe I've isolated the algorithm for making friends.
Sheldon, there is no algorithm for making friends.
Hear him out. If he's really onto something, we could open a booth at Comic-Con, make a fortune.
See, my initial approach to Kripke had the same deficiencies as those that plagued Stu the Cockatoo when he was new at the zoo.
Stu the Cockatoo? Yes, he's new at the zoo.
It's a terrific book. I've distilled its essence into a simple flowchart that will guide me through the process.
Have you thought about putting him in a crate while you're out of the apartment?
Hello, Kripke. Yeah, Sheldon Cooper here. It occurred to me that you hadn't returned any of my calls because I hadn't offered any concrete suggestions for pursuing our friendship. Yet perhaps the two of us might share a meal together. Yeah, I see. Well, then perhaps you'd have time for a hot beverage. Popular choices include tea, coffee, cocoa. I see. No, wait, don't hang up yet. But what about a recreational activity? I bet we share some common interests. Tell me an interest of yours. Really? On actual horses? Tell me another interest of yours. Oh, no, I'm sorry. I have no desire to get in the water till I absolutely have to. Tell me another interest of yours.
Uh-oh, he's stuck in an infinite loop.
I can fix it.
It's interesting, but isn't ventriloquism by definition a solo activity?
What you're going to see is you've got a solution
Tell me
here.
another interest of yours. Is there any chance you like monkeys? Yeah, what is wrong with you? Everybody likes monkeys. Hang on, Kripke. A loop counter and an escape to the least objectionable activity. Howard, that's brilliant. I'm surprised you saw that.
Gee, why can't Sheldon make friends?
All right, Kripke, that last interest strikes me as the least objectionable, and I would like to propose that we do that together. Tomorrow. Yes, I'll pay. All right, goodbye. All right. Time to learn rock climbing.
So what you should have found with that is there was a sequence that had to happen, and then there was these decisions that happened along the way, and then what he did at the end, there was a loop where it kept going in on itself. So it's an awesome little example from the Big Bang Theory on how to actually use a flowchart to get your ideas around. So what is an if statement? An if statement checks to see if something's true or false. So it's a Boolean expression, then executes the appropriate statements. So Python has three kinds of conditional statements. It has an if, which checks to see if something's true or false. If it's true, do something, otherwise carry on. I call this one the postbox condition. So one of those old school postbox with the little flag on it. If the flag's up, you know you have mail. If it doesn't, you know you don't do anything, carry on. Okay. The next one then is an if-else statement. And the way this works is basically a fork in the road. So if it's true, you go this way around. If it's false, you're going down this way, but then you execute this code. So with an if and else statement, like I said, it's a fork in the road, and you're either going to do this option or this option, but you can't do both. Okay. And then the last one is where we can do an if, an elif, then an else, which is more of an interrogation. Okay, so what happens is it comes down here, checks this condition. If it's false, keep going. If it's true, do this statement. And then it goes to this next statement. Is this true? So like what Sheldon was asking. Yeah. And then if it's true, go this way. And then all the way down to your else. If this is true, do this. Otherwise, do that. And it comes back through. Now, with an if, else statement, just to throw a little spanner in the works, the else is optional. Okay. So if we think about like a video game where we're pressing the keys, we only want to do actions if we press the WASD. So if we press W, move forward. If we press the S, we want to move backwards. The A, turn left. The D, turn right. If we don't press anything as a default case, we don't want it to do anything. Okay, so sometimes the interrogation, you don't need to do anything. So to begin with an if statement, like I said, it comes down here. This is the simple postbox option, right? So what happens is if this condition is true, you execute these statements. Otherwise, you just carry on. Okay, so if the condition is true, do something. Otherwise, we carry on. So an if statement in Python will look something like this. If this condition here is true, then do this. Okay, so if it is a reserve word, again, it will turn orange for you in Python. So it's a special word that you can't use apart from this condition. Then the condition will be evaluated like what we just did before in the little example. And then that will come back as either true or false. Yeah. Then we put the snaky by it, or the control structure with the colon, means that a control structure is about to be used. And then we indent by 4 spaces. Now, the reason why we indent means that all the statements that are in here are attached to this condition that we've checked. Okay, so if we don't indent, it doesn't consider that. It's not going to branch out. Okay, so the 4 spaces are super important. In some programming languages, they actually wrap this up in curly brackets. So they'll put a curly bracket here and then a curly bracket down here. That is sometimes useful because then you can see exactly where the problem is. But the benefit of Python is you don't need to write that curly bracket each time. As long as you've got your indentation right, everything will work. Okay, so the way this works will be if the condition is true, the statements or whatever's been written underneath here will be executed. Otherwise, just carry on as business as usual. Okay, so what we're going to do is we're going to build our own little if statement just in Python. I'm going to write a little script, and it's going to look something like this. Okay, so we're going to go x is equal to 2, y is equal to 4. If x is less than y, then, so snaky by it, and then we indent by 4 spaces, print x is less than y. Okay, so I'm going to open up idle again. Okay, and then what we're going to actually do is make a script this time, just because we're going to do more than one line, and we really should see this as we're playing around with it. Okay, so I'm just going to save this. Let's go if statement .py. So don't forget to put the .py at the end. Okay, if statement .py. Cool. Okay, so we're gonna bring this a little bit lower. Shrink that guy down. And we can pull that over here. And awesome. Right, so we're gonna write our script. So we're gonna go x is equal to 2. Then we're going to go y is equal to 4. If x is less than y, snaky bite, and see how it automatically indented it for me because it saw that I wrote an if. Print x is less than y. Close the bracket. So then we're going to save that, press F5, run it, and that was true, right? So because 2 is less than 4, it does it. Now, if we change this around, let's say I made that x equal to 10. When we run this, nothing should happen, okay? Because this condition wasn't true. So if this is true, you're gonna do this. Otherwise, you don't do anything. And that's how the fundamental if statement works, okay? Cool. So x is less than y in this example. So have a go, just pause the video, use the code that we just wrote up, and create the following program. Print out b is greater than a when testing two variables where a is equal to 33 and b is equal to 200. So just pause the video and have a go yourself. Okay, welcome back. So what we're going to do is we're going to try and build this ourselves. So we're going to go a is equal to 33, b equals 200. And then we're just going to write the if statement. So if b is greater than a, snaky bite. And then we're going to print b is greater than a. So let's see if this runs. Cool. Awesome. Worked well. Okay, so what should have happened, we've initialized the variables, okay, and then the output is correct. So that matches if these things were true. Now you could have just been a bit of a smart aleck and said print out b is greater than a no matter what, but then you wouldn't have been able to actually check it if we changed the values of a and b, okay. So notice that there's the indentation. So breaking this down again, an if statement has an if, it checks something. So it's checking something in the middle here. It always has a colon or a snaky bite at the end. And then it indents in for all the statements that need to happen underneath it. Okay. And you can write as many statements as you want underneath that as well, just so that we're clear on that. So we can then go print, here is something else. And then down here, we could go print, this will always happen. Right, so if I run that now, see how it's done 3 lines of text? But if I change the value of a, let's say we make it 300, so then it will never, those 2 lines of code there will never be executed. So if we run this one now, see how it only did the last statement, not all of them. Because when we looked at our code, this was not true. So therefore this never gets executed. which is really useful for computer scientists. So we get the option to choose whether or not that happens or not. Okay. Cool. So indentation is super important. We need to make sure it happens. So if there's spaces at the start of the code, we need to make sure that they indent in. Now you can do if statements inside of if statements. Usually I think they're trying to minimize it down to 4 statements. Once you get past that, it's not really that efficient. So please be mindful of that. Very important in Python. Without it, programs will not run with this indentation. Okay, so make sure whatever, if you choose 3 or 4 statement indentation spaces, so pressing space 3 times, you always use 3. So in this case, this would be 3 across, then this might be 6 across. Okay. When using control structures, at least 1 space has to be used, but by convention, we like using 3 or 4. Just so that it's easier to see where the if statement starts and ends. Okay. By convention, most people use 4. I use 4 personally. Sometimes people like 3, but 4 is okay. And then, yeah, that's basically it. So if we looked at our original one, this had 4 spaces, so it works. So this is legal. This one has no spaces. So therefore, when it comes to this if statement, it doesn't have anything to do after it's been executed and been true. Okay, so this is actually illegal because it doesn't have those 4 spaces. So spaces are super important in Python. That's one of the most important fundamental things that you must do. Okay, so then we're on to the next one. So the if-else statement. So this is a little bit different. This one basically comes down and checks to see if something's true. If it's true, you go this way around and execute these code. If it's false, you go down this way and execute this code. Okay, so I call this the fork in the road. Okay, so if the condition is true, do something, otherwise do something else. It's as simple as that. Now this one, if you get to this part of your program, you will always execute something. Okay, so it'll either be this code or this code. There is no option of not doing anything. Okay, so the previous one, if it was false, you could get away with doing nothing. Whereas with this one, if it's true or false, there will always be a true or false statement. Okay, in Python, it's exactly the same as before. So if we put our hand over this part down here, you'll see that the if statement looks exactly the same. Okay, what happens now though is we put an else statement underneath it. Now this is where it gets a little bit tricky because we know that it has to happen. When we use else, we don't actually have to say what the condition is. Okay, else is basically you're just going to do this, right? So if we think about it, if this is true, you do, and you've evaluated what the test was, you're going to do this. Otherwise, you just do that, and you don't have to even consider what it is. Basically, it's either true or not true. Okay, so for the probability people out there, when you do the probability of an event and the probability of not an event, they always add up to 100%. Same with this. When you do this event and you check it, you're either going to do this, otherwise you're going to do that. So 100% of the time, you will always execute this bit of code. Okay, so if is a reserve word again in Python, same as before. This is the condition that gets evaluated to either being true or false. And then snaky byte is used for both the if and the else at the end. So that means that a control structure has been used. You then make sure that the else is in line with the if, okay, because this control structure is connected with that. Okay, you don't put the else in indented because you don't want it to be executing these statements. Okay, so it's either going to do this, or if that's false, it's going to skip straight down to here, and then it's going to execute this code. So if the condition is true, it will do these statements. Otherwise, it will always execute these statements. Okay, so a little demonstration with it. Here's the code. Okay, so we're going to just type this up into idle. So we'll go back to our idle over here. We'll just delete this one, okay? Rightio, so here we go, delete. So we'll go x is equal to 7, y is equal to 5. If x is less than y, snaky byte, print, parentheses, x is less than y. Close the brackets, and then I'll go back in line, so then it has to be underneath the if statement, else, snaky byte, print, y is less than x. Awesome. So now if we run that, x is less than y, right? So if we look at that, oh, I got that backwards, don't I? Silly Hendo. Right, so we'll do that, then we'll run it. Right, so y is less than x, which makes sense. Okay, and then if I wanted to change that, make that 22, so it should now spit out x is less than y. Cool. Hopefully that's made somewhat sense when you've seen that. Okay, so basically we've gone define the variables up the top here. We then have an if statement underneath. We've checked this condition. So this is what we did when we worked out whether this is true or false. We then have a snaky bite to mean that a control structure has been used. So if this is true, you then will execute this bit of code. Otherwise, so totally the exact opposite of it. If it's false, then you do that bit of code. But do you see it's a branch, right? It's like a fork in the road. You will either do that or you will do that, okay? There is no in between. There is no maybe, okay? So this spits out that. Cool. Have a go at this one. So your challenge, create the following program. Check to see if two variables, a is equal to 42, b is equal to 64, are bigger or smaller than each other. If b is bigger, print out b is greater than a, else print out a is greater than b. So just a modification of the code that we just did before. So if we bring that back up, okay, and we fill in the blanks. So I'm going to just delete all that. So pause the video, have a go yourself. Awesome, welcome back. Here we go. So we're going to go a is equal to 42, the answer to all things, and then b is equal to 64. We're then going to check. So we're going to go if, and we want to see if b, so the client has asked us to check if b is bigger, print out b is greater than a. So we can do that. So we can go b, if b is greater than a, snaky bite, then we're going to print out b is bigger, sorry, is greater than a. Right. Else, with a snaky bite, print out, parentheses, quotation mark. All right, so a is greater than b, quotation mark. All right, so we save that, press F5, and that should have worked as well. Let's just have a look at the code down here. Yep, so b is greater, which it was. So b was 64, a was 42, and then it printed it all out for us. Pretty cool. Okay, so that's what it should have looked like. The last one that we're going to go through is the if else statement. Now the way this works, if you remember, was like the interrogation. So if something's true, execute this, otherwise come down and check something else. So if this is true, execute this, and you can have as many checks as you want. Each time you're checking, you're using the elif command. Okay, so else if this is true, do this. Else if this is true, do this. Else if this is true, do this. Otherwise, or else, do this. Yeah. So I liken this to the Matrix interrogation scene, right? So is this true? 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 Otherwise, you're going to get this statement to execute. Okay. So it's like an interrogation. So keep testing for different conditions. As soon as the condition is true, do something. Otherwise, do something else. And then just as a side note, the else down the bottom here is optional. So sometimes you might not necessarily have to do the otherwise, like the keyboard example I gave you for player controls, right? So if you've pressed W, you want to move forward. If you press S, you want to move backwards. If you press A, you want to go sideways. Otherwise, if you've pressed D, you want to go that way. And then that's it. There is no otherwise. Okay, so sometimes you might not need to do that, but we'll get into those later. So the structure of an if-else statement looks something like this. So if this condition is true, do this. Else if this condition, so this is a little bit different. You actually have to check when you do the else if. Do this statement, else do this statement. Okay. So if is a reserve word again in Python. So this first bit should look exactly the same. However, the difference is this time around when you're checking the condition, you must check both anything something with an if in it. So if this is true, elif, this is true, and then if you have another elif, you would have another condition that you're checking. Okay, we then have the snaky bite at the end of all the if statements and the elif statements and the else's. And elif is one of those wholly reserved words that we showed at the very beginning. Else is also a reserved word, same as before. So it's basically the same as the fork in the road one, except we've jammed in an elif in the middle here. So depending on the condition is true, these statements are executed. So if this is true, do this. If this is true, do this. Otherwise, do that. Okay. So here's a little demonstration of the interrogation, right? So I've made a variable called x and I've made it equal to cat. And we're going to check to see if that string is equal to any of these. So if it's a dog, do this. If it's a pig, do this. If it's a cat, do this. Else it's not an animal. So if we bring up our little idle again, I'm going to make x equal to the string cat. Okay. And then I'm going to go through and check to see what x is equal to. So if x double equals a dog, snaky bite, we're going to print out x is a dog. Whoop, need to spell properly. elif, and see how it's changed to orange. And then we don't just go elif snaky bite. That's a common mistake. Instead, we need to go elif x is equal to pig, snaky bite, print x is our pig. elif x is equal to cat, print x is our cat. And then lastly, else, so if it's not any of those things, print x isn't an animal. Done. So let's run that. So we'll save it and run. And then cool. So it's able to go through and recognize, boom, 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 goes x is a cat. Great, print it out. Awesome. So I guess you know what I'm going to ask you to do. We got this challenge right using the if else and then the elif statements. Create the following program. Create a set of if statements to check to see if a variable is pizza, pasta, or a schnitty, because we love a good chicken schnitty, or not known food. Let the variable equal to pasta and then check it through with that. So open up your Python idle, okay, and have a go. See how you go with that one, okay? So just pause the video. Cool, so here we go. So we're gonna go x is equal to pasta. Right, so then we're gonna check. So we're gonna go if x double equals pizza. So remember, if we did a single equals, that's a problem, isn't it? That's a common mistake a lot of people do when they're starting out. It has to be double equals because you're checking, you're not assigning. So if that's equal, then we want to print out x is pasta. elif x is equal to, oh sorry, pizza, my bad. Sorry, there we go, pizza. I was thinking about pizza, pasta, it's so delicious. X is pasta. Snaky bite, print x is pasta. I've really messed that up, haven't I? We're going to close that brackets, and it's just if it's equal to pasta, isn't it? We don't have to write what the output's going to be. So if x is pizza, we're going to print out x is pasta. If x is equal to pasta, x is pasta. And then we're going to go elif x is equal to schnitty, snaky bite, print x is schnitty, and then lastly else snaky bite, print x is an unknown food. So do you see, this will always get a solution. Now something that might help you with this to break it down is pressing enter before each of the if parts. So then it's a bit clearer if you get a bit stuck. Okay, so you can read that. If that's true, do this. Else if that's true, do this. Else if that's true, do this. Else do that. Okay, so let's just run this just so that you can see that it works. Bring that up. So X is pasta. Awesome. So that worked. Cool. So that's what it should look like when you code something like this. Okay. So then the last thing that we need to cover is the input function. So an input function looks something like this. So game start is equal to input. Do you want to play a game? So do you want to play a game? You type in yes, game started, and then it will spit out a yes. So to get an input from someone, so from the console, we literally just type input, do you want to play a game? We're going to store this in a variable so then we can use it for a whole heap of stuff. Okay, so just to give you an example, I'm just going to use it straight into here. So if I go input, whoop, let's go X is equal to input. What key do I press? Right. Now what's going to happen when I press enter? What key do I press? And I type in yes. If I now press X, it should have the string yes inside of it. How cool is that? So this allows you to have a bit more user input when you're building your games. And we're going to learn how to build a text-based game eventually. So this is going to be pretty important for us. Okay. So inputs allow you to get inputs from the user by simply assigning a variable and then typing input with brackets and then a quotation mark to ask the question from the user. Okay. The types that you choose help do some error checking. So you can actually wrap around it saying it's a string or an integer or a float. So for example, if I wanted to get someone's name, I would go name is equal to string input, please enter your name, and then another bracket. So this typecasts what this has to be. Now, if they don't enter a string, which is pretty hard to do because anything you type will be a string, it won't work. Okay. You can then also typecast it to be an age. So in this case, I've typed it to be an integer, right? Which then allows you to control what's being typed into it. So let's just do that example because that is pretty powerful. We go back here. All right, so right down the bottom, we're going to go age equals int, open brackets, input, open bracket, please enter your age, quotation mark, parentheses, and one more parentheses to match the int. So then it's going to spit that out. Please enter your age. And I'm going to say I'm 25 because I've always been 25. Right. Now, if I type age, I get that. And then the really cool part, because I've cast it as an integer, I can do this, age times 2. And it gets a bit closer to what my age really is. Oh, no, I'm just joking. Okay. So you could also do age minus 15, right? That's probably a bit too young. No, not that. Okay. So that should give you some ideas. Then you can also do the float. So you can typecast it to be a float, which allows for decimal places. Awesome. So we have this amazing website here called Holy Python. We're going to try and do the if practice, which is this link here. In the next video, I'm going to go through that. And then on top of that, if you finish that and totally blitz it, I've found this really awesome extension site. So hackerrank.com basically is an online site. It's totally free. You sign up. And they have a whole heap of these little practice questions like this that you can go off and try and solve, which is really, really, really awesome. Okay. You can actually get your rank up so you can become one of the best Python programmers on the planet, because it's literally worldwide. And then the really cool part with this as well is you get to see other people's ways and solutions of how they solved it. Okay. So this is the challenge down here. I'll put it down in the video. Have a go at that. I'm personally thinking about actually trying to show videos of how to do Hackerrank and see if I can get my ranking up as high as I can. Awesome. So hopefully you've learned a little bit about if statements today. So we should know there's 3 different types. First of all, there's the if statement, where if it's true, do this, which is the postbox version. Then there's the if else statement, which checks to see if it's a fork in the road. So if this is true, go this way. Otherwise, go this way. Otherwise, there's the interrogation, where you check to see if this is true, do this, else if this is true, do this, else if this is true, do this, else if this is true, do this, otherwise, else at the end, do this. Okay, and they're all based on the truthness. So it's either true or false for the conditions that you're evaluating each time. So hopefully you learned something like that along the way. Please share your comments down the bottom. I'd love to hear your feedback. And also, if you can, swing us a like and subscribe. It helps with the YouTube algorithm to try and get our word out there. And yeah, thanks again. See you next time on Steam It with Steve. Adios.